Good evening, JEE enthusiasts. Today I'm going to take you on a spin. We're going to go really high speeds and we're going to see what is the maximum speed with which you can go on a curved road. And who doesn't like spinning? It's so nice. It's an amazing feeling to drift your car or to drift your bike and go along that curve, that nice smooth bend. Straight roads are often very boring, they're plain, but the curves are the ones which make your life more adventurous. So you always learn when you move, when you drive, when you go ahead on a curved road and not on a straight road. So that's me, Shreyas, your master teacher for physics at Vedantu, going live. And welcome all the JEE enthusiasts and welcome all the new members to this family where we teach you, where we train you to crack one of the most actually difficult exam in the world. Yes, so all the 11th standard, all the 12th standard and all the dropper students are welcome here to this channel. It's a very unique channel. It's a English channel where we teach you all the concepts, be it 11th, 12th or for droppers. So welcome aboard. My name is Shreyas and I'm the master teacher. And I'll be conducting all your sessions here, and I also conduct many of the sessions in the regular classroom, the online classroom that is at Vedantu. So I've been teaching for quite some time, like many of you already know, and my aim is to, just like I have produced so many ranks before this and so many of my students are already in the prestigious institutes, I want more of you to get in there in the next 1-2 years depending on which standard you are in. So welcome aboard. Let me just say hello to everyone. Hi Science Priya, Akansha, Navmi, Ratan, Pratik, Jumna, welcome. Hi Juhi, hello Vish, hello Barney, hello NM, Arvind, welcome. Hi Tigatri, hello Palak, hello Kirito. Welcome. So guys, unless and until you type on the chat box, I wouldn't know that you guys are there. So I see the chat box right over here. It's on my right side. There is a second screen on which I read all your chats. Welcome Dinesh. Welcome Pavni. Welcome Anu. Welcome aboard. Yes, Yui, why not? Hello Santur. Welcome. Yes, so today is an amazing session and let's see what it's all about. And in case you are new to this channel, do not forget to subscribe, and even when you have already subscribed, do not forget to like, because the way YouTube works is unless you like and subscribe, you won't get all the video feeds and you might probably miss out on all the sessions that we conduct over here. So do not forget to like just right now, do not miss it, and also subscribe. All right, and today we are going to see how the motion happens and why that motion happens in a circular path. In the previous session, I have talked about circular motion. We have discussed velocity, angular velocity, and so many other things, and you know, the angular acceleration and stuff like that. But now let's also think, why does a particle going around a circular path turn? And let's see this interesting conversation between Pandu and Champa out here. Yes, a lot of people are saying hi Champa, some of you are saying hi Pandu. Very good. Yes, I'm going to start class 12th portions also next week. You will see in the next week's timetable it will be there. All right. So Wish loves Champa, it seems. Okay. So Pandu is asking, Champa, I hope you got how circular motion happens. And Champa is like, yes, it was quite a roller coaster ride. If you remember, it was actually a roller coaster ride, right? We saw a lot of different things about circular motion and all that. In fact, in one of the previous topics, we have also talked about work power energy and all that. If you leave a body or if you leave a cart from the top, with what speed will it come at the bottom and all that. So we have seen things related to roller coaster as well in the previous sessions. So if you have been attending all my classes, I'm pretty sure you would know all this. All right. So Champa is like, what actually causes a body to move in a circular path? All right. So we know that body moves in a circular path, like a planet goes around the sun, or you rotate a string with the stone tied, the stone goes in a circular path. But why does it move in a circular path? So whenever you talk about why, it's called dynamics, and whenever you talk about how, it's kinematics. So why things move the way they are, that is, you're questioning why it is happening, that is the dynamics part of circular motion, and that's what we are going to understand today. Alright, so let's see what is that. Now understand guys, last lecture I have told you, when a particle goes in a uniform circular path, the speed is constant but direction is not, and if direction changes, remember, velocity being a vector quantity, the velocity also changes, and that rate at which the velocity changes in the circular path is called as centripetal acceleration, and centripetal acceleration is always towards the center, and centripetal acceleration, if it is the thumb, and my pointing finger, if it is the velocity, they are always perpendicular to each other. So a particle going in a uniform circular path, you will see that in that uniform circular path, the velocity and the centripetal acceleration are always perpendicular to each other. Now you should also think, if there is acceleration, think, if there is acceleration, there must be force. And we saw last time, for a particle going in a circular path, even if the speed was constant, there was acceleration towards the center. So who is exactly giving that centripetal acceleration? What is it that gives that centripetal acceleration? So let's talk about it, because why don't these objects just fly off? Why should they turn? Why don't they fly off just like this one? I hope you have not experienced one of these anytime. Look at that. Those people are rotating. Oh my God. Oh my gosh, that guy just flew off. Why did that guy fly off? Why was he not able to rotate in that merry-go-round? What is it that was preventing him before, and what is it that made him fly off? So we are going to answer that. Yeah, I agree, epic people. Okay, so let's see. So if they do not fly off, what is it that is keeping them in that path? What is it? So let's talk about that. Also, when moon goes around the earth, what is it that is keeping the moon going around the earth? What is it that is keeping the earth going around the sun? What is that thing which is giving it some acceleration? Well, now let's talk about it, because now after this we are going to start with problems as well. So just imagine, if there is a particle which has some velocity v, and let's say the mass of the particle is m, we have seen before this that that particle will definitely have some kind of acceleration towards the center, which we have called it centripetal acceleration. So that acceleration towards the center is called centripetal acceleration. So now there must be a force which gives that acceleration, because without force you cannot accelerate anything. Keep this in mind. So that force which gives the centripetal acceleration is called as the centripetal force. So this Fc is nothing but a centripetal force. So I can clearly say Fc is equal to mass into centripetal acceleration. Now here is the biggest catch, because nobody tells you this, and that's why you guys are here, and you will realize that in my sessions I always disclose few tricks, tips, secrets, common mistakes, traps which are laid by examiners, paper setters, and in general the difficult concepts in physics which are otherwise very hard to understand. See guys, centripetal force, believe me, is not a force. Like, what the hell is this? Yes guys, centripetal force is not a force, it's a name given to a force. See, we have discussed different types of forces like weight, normal, friction, and then tension, and then spring force, and electrostatic and all that. So these are all actual forces. So you will be like, is this a pseudo force? No, this is not a pseudo force, but this is a name given to that force which acts towards the center. Did not get it? I'll repeat again. Here it is. This is not a real force. This is a force. This is a name given to those forces which provide that acceleration and act towards the center. You'll be like, okay, now I'm slightly getting it. Can you give me an example? Yes, why not? So here is the thing. Imagine right, there is this satellite or moon going around the earth. Okay, so there is a satellite going around the earth, so it is accelerating, so there must be a force. Who is that force? Gravitational force. So gravitational force is the centripetal force. So there is no two separate forces like gravity and centripetal. No, that is wrong. It's just gravitational force is itself the centripetal force. Understand that. Okay. Similarly, if I rotate something like this, let's say I rotate a ball or a stone like this, then the ball is accelerating towards the center. So why is that ball accelerating in the first place? Because there is a force. So who is that force? Well, there is some pulling force, maybe that tension which is there, which is pulling that ball towards the center. So that tension is the centripetal force. There is no separate centripetal force apart from tension. I hope this is clear. Okay, so it's a role of a job role, you can think of it, and there are applicants. Who are the applicants? Like normal, friction, tension, etc., etc. These are the applicants, and the job title or the job role is centripetal. That's what it is. Very good. Excellent. And we know what is the value of acceleration. That is nothing but either you can put v square by r or omega square into r. Either one of them. We have seen both the formulas in the previous session. Omega is angular speed, v is this speed, the linear speed, r is obviously the radius of that particular circular path. Now this force, like I have said before, can be of either gravitation or tension or normal or friction, or I can say electromagnetic. It could be anything. It could be any one of them. It's not an actual force. I hope this is clear. We'll start taking examples, then you will start understanding this. Centrifugal, we'll come to it later on. First, let's understand centripetal, right? Okay. Okay, so I hope you have made notes. Let's start with some problems. Okay, Aarti says yes, and Saurabh also is clear. Very good. Yes, correct, Krito. It can be also a sum of these forces. For example, imagine there is a particle going in a circular path. This is the velocity, okay, and maybe there is some force F1 here, maybe there is some force F2 here, and maybe there is some force F3 here, example. And we know that the acceleration is towards the center like this. Then understand my equation will be little bit different. So always take only those forces which are along this line. Which line? Along the radius. So this is the radius line. So which are the forces? Well, F1 is one force which is along that radius. F2 is not there completely. So let's say this is theta. So which part of F2 will be there? Only F2's cos theta will be there. F2's cos theta is in the direction of acceleration. Just like you solve normal Newton's problems, guys. What do? You split the forces and net force is mass into acceleration, right? So just think which are the forces. F2 cos theta is also there, and F3 is there, but a different component is there. Which component? I think it is F3 cos phi. This will be m into AC. This will be m into AC, and that AC you can write it as v square by r, of course. So if I ask you what is the centripetal force in this case, guys, what is the centripetal force in this case? The centripetal force is this one. These together is called as the centripetal force. Understand? Yo, cool? Understood? This is very important. I hope the concepts are clear now. All right? So let's begin with some problems, of course. So I just told you F centripetal is mass into acceleration. That's normal Newton's second law. And substitute the value of A as v square by r or omega square r. Very good, Palak, Aarti, Sanspriya, Devendra, Pranav. Yes, very good, Navmi, very good, very good. Okay, so let's have a look. So keep all these things in mind. Do not worry, it will all come in the extracts as well. right? But this will be also there in the session PDF, and I hope you are also simultaneously making notes so that in case you forget a formula, because we cannot go back to the previous slide, you can always refer your notes and then start solving the problems. Okay, now if there is a ball, these are simple problems, but I want to do it just so that you get a hang of it. So if there is a ball which is rotated in a circular path, let's say the angular speed of rotation is omega, and let's say guys the radius of that path is r, and I want to know what is the tension acting on it. Well, the tension will act like this, and similarly remember guys, it will be also having some acceleration towards the center. This is how it will look like. So when the ball is going like this, the tension is acting towards the center and acceleration is also there, and by Newton's second law one can easily say tension is equal to mass into acceleration. There is no other force. We are neglecting gravity. It's not in a vertical or circular path. This tension is the centripetal force, and then we can substitute the value of AC, which is nothing but omega square r. So the tension in that string is m omega square r. So please understand, I have not shown tension and then centripetal force. No, that's not what I do. I just show tension, that itself is the centripetal force. Alright, I hope this is fine guys. I hope this is fine. Excelente, excelente, excelente. Let's go to the next part. What if similarly there was a planet? There was a planet going around, okay, around some another planet, let's say. Maybe there is a planet of mass m1 and maybe this planet is of mass m2. In that situation, understand this planet is going to accelerate towards the center because it has some velocity when it goes around this big planet. Probably this is the moon or a satellite. And who is going to give that acceleration? Of course, the gravitational force. And then I will say gravitational force is equal to mass into acceleration. That's Newton's second law. And acceleration, guys, what is it? It is velocity square. But this mass is which one? This is m2 mass, because I'm talking about this mass over here. So m2 v square by r. Okay, but we can also substitute the value of gravitational force. In case you remember the formula, it was nothing but g m1 m2 divided by r square. That's the force formula for gravity, and you can see r and r gets cancelled. In fact, m2 and m2 also gets cancelled, and you'll get g m1 by r is equal to v square. That's what you will get. m2 has gone, one of the r's has gone. Therefore, in fact, you can find the speed to be root g m1 by r. Alright, so that's how you can find the speed of the planet or the satellite going around a big planet. Such an interesting problem. Yes, that velocity can be orbital velocity VSG. Yes, correct. Yes, very good, very good. Clear. Clear, everyone? Shall we go ahead? So this is how you can find the orbital speed. Okay. Very good guys. So now, before we go ahead and we solve some more problems and I tell you about centrifugal force, again let me remind you the pro subscription offer of 20% discount where you get unlimited live classes, guys. You get yourself enrolled into live classes just like you learn over here. In our regular classes, let me tell you, there are something called as class teachers. Right now you are chatting, right? But YouTube does not have that facility where somebody can moderate and sit and answer all the doubts. In our regular live sessions, what we have something called as the class teachers. We follow a two-teacher method. So I am the one, let's say I'm the master teacher who is teaching. The class teacher will be answering all your doubts and he'll be responding to you, and a set of students get one class teacher, another set gets another class teacher, another set gets another class teacher. So you get personal attention, plus you get all the notes in the form of PDF. You can watch replay any number of times, and also guys, you get nationwide test series and the regular assignments, just like you get the drills here, but there you get even more questions, you get modules, you name it. And also you have the option of learning in Hindi as well as English, which is a very big plus point. Not many institutes offer that. And also you get unlimited access to all our micro courses, special courses for KVPY, boards, Olympiads, you name it. All right. So all these things come at a very reasonable price for droppers if you take it for 6 months. And today, by the way, let me tell you, it's 50% off. Yes, you heard it right. Yesterday it was 20%. Just for a very limited time, very limited time, this has gone to 50%. Yes, Jay, even there are courses for class 11th. There are called micro courses. Yes, there are Jay. Yes, there are. 50% discount. That's a big discount running right now, and you are going to get amazing prices. You cannot probably get bigger discount than this. Ye bus Diwali sale and Children's Day is coming. That's why this is Diwali and Children's Day bonanza. So the maximum discount is up to 10,000. Remember, that's the cap limit, but you get 50% depending on what course you choose. For the 12th standard students, again 50% off. Whatever course prices are there, you will get 50% off with a cap limit of 10,000 rupees again. And for 2022 students, which is 11th standard students, also again you get 50% off. Again a big massive discount guide. Yes, Children's Day offer, the Diwali offer going on right now. How do you get it? You have to use this coupon code SHHPRO. You get everything. You don't have to buy one course separately. Just like, see guys, if you want to watch a movie in theater, you have to pay so many rupees. You pay 200 rupees to watch a movie. But on Amazon Prime or anything, how much do you pay? You just have to pay 500 or 1000 rupees or something like that for a year, and you can watch unlimited movies. It's still same way. You don't have to pay for separate coaching for separate teachers. You don't have to travel anywhere. Just pay once. That's it. Done. Khatam. All right. So use that coupon code. The link is in the bio. All right. Great. Okay. Yes, Children's Day. I am planning a very special session for all of you. Do you know what I am planning? Do you know what I am planning? A special lecture for all of you. I am thinking of conducting a very special session. Very special session. Yes. No, not midnight class, but a very special thing is coming. Let me tell you that. And by the way, today on Biotonic channel, which is the biology channel for NEET, I'll be conducting a special lecture. I'm going there as a guest lecturer, and I'll be conducting a lecture on Bollywood and physics. You're going to see Bollywood and physics together. It's a very unique combination, and you're going to see it's going to be really cool. Don't worry, I'm going to conduct a very similar lecture in our channel as well. Okay, so wait for the suspense, guys. I have a very special lecture on 14th of November or Children's Day. All right, for Children's Day. So keep our family growing. We are almost about to touch, I think, 7,000 subscribers already, and that's a big number. Very good, very good. Chalo, let's start with the next problem. A string will break when you have 9 kg or more attached to it. Anything 9 kg or more, it breaks. So one end of the string has a mass of 2 kg, length is 5 meters, and you rotate it. What should be the RPM so that the string does not break? Neglect the gravitational force. It's not like a conical pendulum. Just think of tension. That's it. Come on, let's see how many of you can solve this now. Let's see. I'm starting the timer for 1 minute. Remember, the final answer should be in RPM. Come on, let's do this. Prija, Biotonic is actually a Hindi plus English channel, so I'll be using Hindi and English combination there. All right. Okay, come on, guys. Oh, Science Priya, we have reached 7K. That's cool, yeah. That's cool. Very good, Jumna. All thanks to all of you. Yanamdala, I'll be starting with electrostatics of 12th standard next week. Thank you, Palak, so much. That's so nice of you. I'm really great. Really glad. You're always welcome, guys. Come on guys, give me the answer. Okay, let's see. So here is the thing. The tension maximum value, all right, is basically, think about it, the maximum tension that can be there is 9G, which is nothing but 90 Newton. And just some time back, we just figured out that the tension in a ball which is rotating, all right, with certain angular speed omega, we just figured it out. It was nothing but m omega square into r. That's it. So just substitute the values. Tension is nothing but 90, mass which is being rotated is 2, and omega is what we need to figure out. Radius is nothing but 5. So basically omega square is nothing but 2 5s are 10, 1 0 goes, and therefore I'll get it as 9. Therefore omega is 3 radians per second. But that is radians per second. How do you convert it into rounds per minute? Think about it, guys. 1 round is how much? 2 pi radians. So think about it. 1 by 2 pi rounds, correct? 1 by 2 pi rounds will be nothing but 1 radian. So how much will be 3 radians? Can you think of it? 3 radians will be 3 by 2 pi rounds. But that is per second. So how do you convert it into per minute? Because that's what has been asked. Yeah, think about it. It's per second, right? Multiply by 60. So this will become 3 divided by 2 pi multiplied by 60. That will become rounds per minute. That will become, yeah, into 60 rounds per minute. So you can cancel it. It will become 30. 33 is 90. So 90 by pi RPM. That's the final answer. I hope this is fair. Fine. Okay, very good. I'm seeing all your chats. Most of you got it. Oh, well, Achyut, no problem. Just join in. It's okay. You can just blend in. Let's see how much ever you can understand. You can always replay the missed part. Okay. Guys, never miss the starting of the lecture, because our starting of the lectures are always killer, and I straight away dive into the lecture right from the beginning after 1-2 minutes of talking out there. All right. Okay. So let's go ahead to the next question. A conical pendulum. What is the meaning of conical pendulum? Right? You take a string, suspend a ball, and you rotate it like this and leave it. You will see that the ball goes like that. Okay, so the ball goes like that. The string forms or goes along the surface of a cone. That's why it is called as a conical pendulum. But when you take that string and leave it here, when it oscillates like this, that kind of behavior is generally called as simple pendulum. Alright, so a simple pendulum oscillates in one plane, but a conical pendulum, you will see, it traces the surface of a cone. That's why that name has been given like that. Yes. Now, the mass is 5 kg and the length of the string is 10 meters. It moves in a horizontal circle. So this dotted line is horizontal. Speed is 20. If the string makes 30-degree angle with the vertical, then find the tension in the string and also the time period. So let's do this and let's see what should be the answer. Now, first of all, I'm going to start with the free body diagram of this guy. So what is the mass? Well, the mass is nothing but 5 kg. Now, if you look at the forces acting on this, let's think about it. What are the different kinds of forces acting on it? One will be its own weight, which will be 5g, and next will be the tension, and of course it should have some acceleration towards the center this way. So there is AC over there like this. Now it is already given that the string makes an angle of 30 degrees with the vertical. So naturally this angle over here should also be 30 degrees. Now why did I do that? Because see, if I want to find what is the tension, etc., etc., I'll have to split the tension force into two components. Now if you visualize it carefully, in the y direction, guys, there is no acceleration. Why is the acceleration here? because the center is at O, the acceleration should be always directed towards the center in that plane, horizontal plane. So in the y-axis, is there any acceleration? Nothing. So who should balance whom? I believe tensions cos theta should balance 5g. Completely they should balance out each other. So therefore tension cos 30 is nothing but root 3 by 2. 5g means 5 into 10. So hence tension will be nothing but 50, that will become 100 by root 3, that is newtons. So I have got the value of tension also. Great. Then what else do we need? Find the tension in the string. Okay, done. And also find the time period. Okay, we need the time period, guys. How do we get the time period? Think about it. Well, in this big triangle out here, this is the radius. And do I know the length of the string? Yes. The length of the string is how much? It is 10 meters. Correct? The length of the string is 10 meters. So I feel we can find out the radius very quickly because R is opposite this angle of 30 degrees. So I can immediately say R is nothing but 10 sine 30, and that will give me nothing but 5 meters. So that is the value of radius. Now why did I find radius? Because I can find the time period, guys. How can I find the time period? Think about it. Time period will be total distance, which is 2 pi r, divided by whatever speed with which it is moving. So what speed is it moving? It is moving with a speed of 20 meters per second. So just substitute everything, guys, and you should get the answer. Yeah, I hope this is clear. So you can do that. So this is nothing but time period. This is not tension. This is nothing but time period, and that will be nothing but 2 multiplied by pi multiplied by 5 divided by 20, of course, and 20 was the speed. So just do that and you should get the answer. So 2 5s are 10, and that goes, so it should be pi by 2 seconds. Is that fine, guys? Thank you, Yanandala. Thank you, thank you. Okay, very good, very good. So this is how you solve problems on conical pendulum. Okay, this is how you solve problems on conical pendulum. Very good. Chalo, let's go to the next question then. Let's go to the next one. It's a very interesting one. Okay. Now, look at this. Often when you go on a bicycle and somehow you feel like doing some stunts, you always want to go in a small circle. You want to turn the cycle in a small circle. But if you go in a very small circle, you will skid. So we'll try to explain that using circular motion concepts. So here this cyclist is traveling at a speed of 36 kilometers per hour and the coefficient of friction is 0.4. What is the smallest radius? Because think about it, if he goes in a big radius, he will not skid, but if he goes in a very small radius, probably he will skid. Here it will not skid, and understand there will be one particular path where he will be on the verge of skidding, and this is what we will try to figure out. What is the radius of that path with which he should turn so that he is just on the verge of skidding? Anything less than that he will for sure skid, anything more than that he will not skid. So let's try to figure that out. Now imagine the cyclist is going this way and is turning towards your left. So you are seeing him from the back. So this is the cyclist, the mass is m, this is that road, okay, and he's going inwards and also turning like that. All right, so just think of it like that, he's turning that way. Okay, now okay, let me just draw it again over here. What are the different kinds of forces acting on him? Well, there is obviously mg like this, and the ground obviously will exert a normal force, right? And do not forget, he's also going to accelerate towards the center, guys. Yes, he's going to have centripetal acceleration because remember he's turning like that, correct? So the center is somewhere here, and in fact this one is nothing but the radius of that track. So the center is somewhere here. Now my question to you is, which side is the friction? Is it outwards or is it inwards? Yes, I'm coming to that. Where is the friction, guys? Where is the friction? Where is the friction? Is it outwards or is it inwards? I'm reading. Outwards or inwards? Okay, some of you are correct. Guys, think about it. If the acceleration is here, wherever is the acceleration, that's where the force is. How can friction act there when acceleration is here? Who is then giving this acceleration? Obviously, friction has to act this way, and that would be the static friction, like this. How can it act outwards, guys? In fact, your tendency to slip is outwards. So what does friction do? It prevents the tendency to slip outwards by acting inwards. Okay, so now what will your equation look like? Your equation will look like this. Fs is equal to m into AC. What is the value of AC? It is nothing but V square by R. What is the value of Fs? I do not know that yet. I'll just put it over here. Now, from this point, okay, so let's see. If radius decreases, think about it. This term will decrease. So what will happen to the friction? It will increase. But remember, friction can't increase by any extent. There is a limitation to that. So that's why there is also a limitation till which radius can decrease. So when friction has increased by its maximum amount, all right, that time it will be Fs max, and that's when it will be mv square by r minimum. That's what the equation will look like. I'm trying to solve in detail. A lot of people skip all these steps, and a lot of people then do not understand this problem completely. So that's what I'm trying to do. Yes, radius will also be limiting radius. So r minimum, that's the least radius when you're on the verge of skidding. So what is Fs max? Think about it. Fs max, guys, is nothing but mu into n. But what is n? It is nothing but mg. Okay, so I just substituted that. So it will become mv square by r minimum, and mm goes off. So therefore, I will get r minimum as, take r minimum over there, v square will be left over there, m has gone out, mu and g will come downstairs. So that's the value of the minimum radius. Now if you want, we can just substitute all the values and we'll get the answer. So r minimum, I'm just solving it here, will be v square. What is v? 36 kilometers per hour. How much is 36 kilometers per hour? It is nothing but 10 meters per second. So 10 square by mu, which is 0.4, into g, which is 10. One of those 10s will cancel out. So it will be 10 by 0.4. So you can make it 100 by 4. So that will be 25 meters, I believe. Okay, I hope this is clear. I hope this is clear. So that's the least radius which he can go. Anything less than that, he will skid. So that's how you're supposed to solve this problem. Great. So this is the level of analysis you need to do when you're solving problems, even if it is a simple problem. So I've started right from the basics and then slowly gone to why it tries to skid. Okay, so let's go ahead and let's now obviously talk about centrifugal force. So let's see. First, have a look at this simulation. Have a look at this simulation, guys. This is a very good example of centrifugal force. Now we can see while drifting, very often the cars go towards the sides. The cars move towards the sides. Why do they do that? That's what we need to explain. And have you ever seen this happening in your car or in a bus? There's something kept on the dashboard or something kept on the seat, and you will see they suddenly start moving outside. All right, have you seen this happening? Yeah, okay. Now here is the thing. Now imagine you are driving in this car and you see these oranges start moving towards the left. What will you say? Who has pushed them? Who has pushed them? Is there a force acting on them towards the left side? Actually speaking, there is nothing acting on it towards the left side. Yes, guys, I'll tell you why there is nothing. Here is the thing. Here is the thing. If, let's say, these oranges were still there and your car is going like that towards your right side, then understand the force on the oranges will be towards the right side. Which force? Friction. So the friction is making those oranges turn like that. So the oranges are turning like that with the car, assuming that they are not sliding like this. So friction is turning those oranges towards that side. But what if the friction is not sufficient? Then the friction won't be able to turn it there. So for you, the oranges or those blocks tend to move towards your left side. So understand, friction was incapable of turning them. It was not able to give them the necessary acceleration to turn along with the car. So for you guys, it has turned or it has skidded away. Understand that. That's very important. So it's not a real force which is pushing them. No, it's not a real force. It's a fictitious force which is called as centrifugal force. Centrifugal force is a pseudo force which acts in a rotating frame. So when you are in a rotating frame or when you are a turning frame, that's when you will experience or you will apply something called as centrifugal force to explain this kind of weird behavior, or else you might call this as black magic or something like that. So just understand one thing. Just understand one thing. I'm going to change your mind completely. See guys, imagine this was the top view of a merry-go-round, okay, and there was something over here which was going like this in that curved path. So you will be like, okay, there was a force like friction maybe which was pulling it inside, and that is why it was accelerating and it was going in a curved path. Correct? Now just imagine friction disappears. Just imagine friction disappears on that merry-go-round. The merry-go-round is still rotating. What will happen to this ball? Do you think it will go like that? I don't think so. I feel that it is going to go in this direction. But a point on the merry-go-round will go like this. Now think about the ball which will just fly off because there is no friction. It's completely smooth in this case. In this situation there was friction. What will a person sitting on the merry-go-round feel? Okay, that orange or that ball or that box or that person is just flying off. Oh, so there must be a force outwards. But actually, is there a force outwards? Think about it. I don't think so there is any force outwards. I just feel that this ball is obeying Newton's first law. It's just going in a straight line because there was no force because of the smoothness. So from the ground frame, it is very clear that the ball should have gone in a straight line. But the moment you shift in that rotating frame, you feel, oh, something is wrong. Why is it going outwards and all that? So to satisfy that, we introduce this force called as centrifugal force, which is not a real force. I hope this is making sense now. I hope this is making sense. All right. Very good. Very good. Very good. Clear? Okay, so let's see what's the value of this centrifugal force. So here is the thing. If you have any object of mass m and let's say that object is at a distance of r and you yourself are in the rotating frame. You are in the rotating frame which is rotating at angular speed omega, then the centrifugal force is always outwards. This is a pseudo force, understand? So this is the pseudo force which acts on you or on that body. This centrifugal force, which is that pseudo force, will be given by mass of the body into omega square into r. So that's the value of the pseudo force. What is omega? Omega is the angular velocity of the rotating frame of reference. M is obviously the mass of the body. R is the distance from the axis. That's what it is. So this is the formula which you should keep in mind. All right, so pseudo force, which is the centrifugal force, is m omega square r. Keep this in mind. By heart this, write it down in your notes so that you can solve the next question now. Yes, it's like the pseudo force. It's like the pseudo force in rotating. In normal Newton's laws, we have seen ma. So here instead of a, you have omega square r, or you can also use v square by r. It's also fine. Okay, v square by r will also do. Also keep this in mind. Lot of people tell you guys that centripetal force and centrifugal force are action reaction, or they are equal and opposite. Guys, that is wrong. Please do not think of it that way. That is wrong. Please understand that once you sit on the merry-go-round and you see this block or this body over here, you will see that the body is at rest, and in fact you will see the entire world is rotating around you. So that body for you is at rest. It is not performing circular motion in that rotating frame. So it is not even going in a circular path. So where the hell will centripetal force come from if it is not going only in a circular path? So guys, it is wrong to say centripetal force and centrifugal force are equal and opposite, or they are action reaction, they cancel each other. These are all wrong statements. Understand, the moment you sit in a rotating frame and you look at a stationary body, there is nothing like centripetal force. In fact, there is only that pseudo force out there. Get it straight. So one is applied in an inertial frame, the other one is applied in a non-inertial frame. So there are two different perspectives. So they are applied in two different perspectives. So you cannot use them simultaneously. Understand that. Okay. So get this thing straight. All right. So let's solve a question. A 50 kg person is standing on a merry-go-round which is having a radius of 10 meters. What will be the maximum angular velocity so that the person does not fall off? So let's try this out. So here we have that merry-go-round, let's say, and okay, and here we have our Pandu. Okay, so we have Pandu over here whose mass is 50 kg and he is standing at a distance of 10 meters like this, and question is what should be the maximum angular speed. Okay, so here is what I will do. I can do this by ground frame also, but I don't want to sit on the ground frame. I will sit on the merry-go-round, and please let me sit on the merry-go-round. Okay, so I requested Pandu that please let me sit on the merry-go-round and let me observe you. So the observer is over here, and that is the rotating frame of reference. Now in this rotating frame, what will this Pandu appear to do? Think about it, because you are also rotating with the merry-go-round. He will appear to be at rest and the entire world will rotate around you both. Such a romantic scene, isn't it? Did you understand this concept? Yeah? Okay, very good. So what are the different forces acting on Pandu? Well, there is this 50G force, then of course there is that normal force, and remember you are in a rotating frame, so there must be a centrifugal force or the pseudo force over here. So this is the pseudo force which will act, and who will balance the pseudo force? Why should it be balanced? Because Pandu is at rest for that frame. So who will balance it? Friction. So friction will balance it, and oh, is mu given? No, mu is not given. So let's assume some mu. Mu is example 0.5. Let's assume that mu. Now I think we can solve this. Think about it. When you're rotating it with maximum angular velocity, this friction will become Fs max. It's on the verge of sliding, so that's why maximum, limiting, that's it. It's on the extreme. Iske baad it is just going to slip. So I will say in this particular situation, the Fs max will be balanced by the pseudo force, and pseudo force is m omega square r. Remember I just told you about it. And friction force will be mu into n. And what is n? I think it is mg. All right, so let me just put m over here and g. The interesting thing is m just went off and I got omega square as mu g by r. So let me just substitute everything and see what do we get. Omega square will be mu is 0.5 or just half into g, which is nothing but 10, divided by radius. How much is it? 10 meters. Okay, everything went off, so it will become 1 by 2. So omega is 1 by root 2 radians per second. That's the answer. That's the maximum angular speed. Okay, so this omega that we are talking about is the maximum speed. Anything more than that, Pandu is just going to fly off, just like that simulation which I just showed you some time back. I hope this is clear and it explains why that person went off. Yeah, okay. So Prija, I'm now explaining it in detail, but once you get hang of these questions, you will be quickly imagining all these things mentally, you will be quickly drawing all these forces, you will be writing it within 10 seconds. So it's just that I'm teaching you in a proper method because I want to explain you. Later on it will be very, very easy, okay, for all of you. Okay, how about this question? How about this question? Come on guys, let's see how many of you get this. Come on guys, let's see how many of you get this. So 60 kg person rides on a giant wheel. So look at that person, so happy he is. And I asked you how many of you like giant wheel rides, and many of you told that you guys are scared and all that. Anyways, so a 60 kg person on a giant wheel of radius 10 meter, what would be the normal force on him at the topmost point, and what would be the normal force on him at the lowest point of the ride? Assume that the angular speed of rotation is 0.1 radian per second. So let me put a timer for this question and let's see how many of you get this really quickly. Alright, so I'll put 1 minute and 30 seconds for this. Okay, so let's try this out for 1 minute and 30 seconds. So if mu is high, obviously the omega maximum will increase. You can rotate him at a much higher speed, obviously. Come on, come on, come on, come on. Pandu's mass is 60 kg. That's what is given. Come on guys, you can do this. $40 seconds to go. Give me both the answers, guys. Come on, give me both the answers. I'm reading all your chats. Everybody is messing up with the decimals, I believe. Just check your decimal values. Hello Nikhil, join in. Come on, I have given just a problem. Okay, time is up. Let's have a look. So, when this Pandu is at the highest point in that rotating frame, so we are discussing everything in that rotating frame. Remember, omega was already given to us as 0.1. Okay, it is already given to us. So think about what are the different forces acting on him. Okay, so one will be obviously his own weight, and how much will it be? 60 g. Then there will be a normal on him like this. That's how it will be. And remember, because it is a rotating frame and he appears to be at rest, so if he is at rest to me and I'm in a rotating frame, I must apply a pseudo force radially outwards. So the pseudo force will be something like this, and he appears to be at rest, remember, in that rotating frame only. Okay, so if I have not clear about it, I'll mention it here again. Rotating frame, I'm sitting in that, so he appears to be at rest. Now at this location I can clearly say normal plus Fp minus 60g is equal to 0. Therefore, normal force is equal to 60g minus the pseudo force. Now substitute the values. G's value is 10, pseudo force is mass, which is 60, into omega square, which is 0.1 square, into 10. Correct? So I think I can take 60 into 10 common, which will become 600, and it will become 1 minus, this will, yeah, correct, right? Yeah, 0.1 square, which is 0.01. So that's what I will get, guys. I hope you guys are seeing it. It's not exactly 600. I hope you can see that. It is 600 multiplied by 0.99, which is slightly less than 600. Do you see that? It's 99%. Think about it. It is 99% of actual weight. It's the 99% of actual weight. Isn't that clear? Yeah? Then why are we taking 60g? No, we are not taking 60g. 60g is the actual weight. So normal force is slightly less than 60g. And if you have sat in a giant wheel, you would have experienced that when you are at the topmost point, you feel little bit weightless. Why? Because the normal force reduces. The weight apparent at the topmost point is slightly less. It's the same feeling that you get when you are in a lift, which is going downwards, which is accelerating downwards. You get lifted up, you feel that, oh, your weight is slightly less. Remember, we have talked about lift frames of reference in the previous sessions. Same thing happens over here as well. Now, if I go below, okay, so this was 99%. I'm just going to erase it because I need some space over here. Now, if I go below, a similar FBD will come, but there is a small change. You will have normal, obviously upwards. You will have weight, which is 60g downwards, and pseudo force will also be downwards. Remember, it will be radially outwards. So N minus pseudo force minus 60g will be 0 because it is at rest. Alright, so he is at rest, that's the reason. Therefore, N will be 60g plus pseudo force. And now you can see it is obviously going to be more than 600. So 60 multiplied by 10 plus mass, which is 60, into omega square, which is 0.1 square, into R is 10 again. So it will be 600 into 1 plus, this will be 0.01, which is 600 multiplied by 1.01. I hope you see it is 1% more than the actual weight. That is what I wanted you to see. It's more. This is the feeling that you get at the bottommost point of the giant wheel. When you are at the bottommost point, you feel pressurized, you feel your weight is more. It's 1% more. I hope you understood the essence of the problem. In fact, this is the same feeling a fighter pilot gets when he is diving like this. When he is diving like this, he feels he is slightly weightless. Even when you are in a plane, and let's say the plane dives suddenly down like this, what happens? You will jump up and you will feel, oh my God, I just lost contact with the seat. And imagine a plane going like this. Imagine a plane going like this. You will feel all the blood has gone into the feet. Nothing is in the brain. And you will feel more weight in that case. I hope this is making sense. Alright, so that was the essence of the problem. Now, let's do a very cool thing with this Pandu. Let's rotate. I am an evil operator, let's say, at that amusement park, and I am going to rotate that giant wheel so that this Pandu has some fun in his life and he feels completely weightless at the topmost point. Imagine that. Some operator did that to you. You flew off at the topmost point, guys. Because here normal is less, right? So just imagine if that happened. It would be so cool. So let's try that out. If at the topmost point you feel completely weightless, that means normal force is 0. You are not in contact, you are just floating. The only forces which are there are pseudo force and mg, and you are at rest, obviously, in that rotating frame. So I'm in that rotating frame. I observe myself at rest. So obviously pseudo force should balance weight. Pseudo force will be m omega square r is equal to mg. So therefore omega square will be g, alright, mm has gone off, divided by r. G is 10, r is also 10, so it is 1. So omega square is 1, therefore omega is 1 radian per second. That's quite a huge speed, I'll tell you why. What should be the time period? That's what they have asked. So time period will be 2 pi divided by omega. So it will be just 2 into 3.14 divided by 1, which is 6.28 seconds. Now this is the answer. Now imagine just 6.28 seconds. It's not very small. Almost like 6 to 7 seconds. If the giant wheel goes like this, and it takes 6 seconds to come back over here, believe me, you would have felt completely weightless over there. Yes, just the speed. It's not very fast. It's going around 6 seconds. It's taking around 6 seconds to come back to the same point. You would feel that you are weightless at the topmost point. Isn't it cool? Isn't it amazing? And normal will be high sorrow at the bottommost point. So in fact, you will get weightless feeling at the topmost point, but when you're at the bottommost point, don't ask me. I mean, you will feel all your blood is in the feet because everything will be pushed down. The pseudo force is going to push everything down. Your weight will be tremendously high. That will be so cool, isn't it? What a problem, and what a way to learn centrifugal force and everything. So guys, if you want to learn like this, do not forget that I conduct my regular sessions, micro courses, and teachers like me only teach in the normal batches as well. And also you get tests and additional practice. And remember, there is 50% off going on right now only if you use the coupon code SHHPRO. Those are the letters that you have to type in. The link is in the description box. Remember, the offer is only till 11th of November. It's a special offer for Diwali and Children's Day. Maximum cap is 10,000 rupees on any courses that you use. You can also share this coupon code with your friends or relatives in case they need any help and they want to enroll themselves into Vedantu. Thoda madad karo, and you can also take some commission, hai na? Okay, so this is a link for the Telegram group where we post all our updates. And do not forget to join in because I'll be posting many things over there. And if you have enjoyed today's session, what should you do, guys? Obviously you should like, and if you're a new user, what should you do? You should subscribe, because without that you will not get notified again. Alright, so I'll be seeing you in 1 hour on Biotonic channel, and tomorrow I'll be seeing you again over here in JEE Enthuse channel. Tomorrow I'm going to conduct my session on one of the difficult problems in advanced in kinematics and mechanics, so the dynamics part. All right, Newton's laws, kinematics. I'm going to take some good problems tomorrow at 11 AM sharp. Do not miss it. They are good level problems. Come prepared. All right. So see you at 9 PM on Biotonic channel where I'm going to talk about Bollywood and physics. It's going to be very exciting. See you there. Bye bye. Good night. Take care. Have a great time.